Hello, everybody, and welcome to today's webinar around best practices for achieving code coverage goals with JUnit. My name is Mark Lambert, and I'll be working with my colleague, Brian McLaughlin, today on helping really show you guys some of the best practices for getting a handle on your unit testing practice and using it to really achieve the coverage goals that your organization is looking for you to hit. Now, before we go ahead and jump into that, though, just a couple of housekeeping tasks around Zoom, the platform that we're using today for the webinar. There is a chat available. If you experience any difficulties or issues during the course of today's webinar, please send a chat message there. We have a team online that's going to be able to kind of help you with that. There's also a Q&A box. So we'll be doing Q&A at the end. Usually we get a lot of questions during these type of webinars, so feel free to throw them in there as we go through. Again, we have folks on the line. They'll be able to help you kind of with some of the questions as we go through the session today. So there's no need to hold the questions all the way to the end. Now, with that being said, there's also a little raise the hand button too. So if you wouldn't mind just clicking the raise the hand button, let me know that you're able to hear me and see my screen okay? Great, thank you very much. I see that. That's fantastic, thank you. So with that being said, let's get into the webinar for today. As I said, my name is Mark Lambert. I'm the Vice President of Products at Parasoft. I've been with Parasoft getting on 16 years, working within the software quality space, and unit testing was certainly one of the areas where I first started cutting my teeth at Parasoft with some of our unit testing technology for Java and C++. I'm joined by my friend and colleague, Brian McLaughlin. Brian has been with Parasoft over 12 years now and really has been instrumental with establishing our JTest product and the new enhancements around it over the recent years, specifically around establishing best practices and streamlining that process. So Brian will be using JTest today as he's talking through the best practices. He won't be going through features and functionality, but he'll be using it as a tool to articulate some of the points that he's going to be making coming from a number of his blogs and published articles on places such as the Oracle journals. Okay, so before we jump into unit testing in itself, though, it's worthwhile pointing out where unit testing fits into a software test automation strategy. And many people, I am sure, are familiar with the testing pyramid. Certainly, if you have been on one of my webinars previously, you've probably seen this in almost every one of the webinars that I present. I'm a big proponent of this strategy of establishing a solid foundation of unit tests, which are granular. They're easy to execute. They're easier to diagnose. You get a nice broad set of code coverage. Moving up through the testing pyramid with less and less tests at each of the layers. The next layer up is API testing. Testing RESTful services, for example, great way of validating business logic that sits behind the functional UIs. Obviously, the UIs are the things which are intuitive. They're the things that people understand how to work with. And we'll talk about how to leverage the functional testing later at the end of today's session. We'll talk about how we can leverage those practices that are going on with the organization across this pyramid. Now, there is, in my mind, though, a missing layer to this pyramid, and there are a number of research articles from Gartner, for example, which actually talk about this as well, which is making sure that you're building your testing practice on top of a solid code base. Because as we all know, you cannot test quality into an application. You know, if you're just doing testing and presuming that's your quality process in itself, you're never going to actually make sure that you're starting from the right point. This is where you leverage deep code analysis, going beyond simple linting tools to uncover reliability and security issues within your code base. Not a focus of today's conversation, but certainly one that Parasoft has talked about many times. And you'll actually be able to see other webinars on our webinar series that talk about application static analysis. The bottom line is, if you take this approach, you're going to have an easier way of scaling your test automation strategy and ultimately getting to your goal of building quality products, both from the use of coding standards as well as test automation practices to help uncover those regressions earlier. So let's dig into unit testing specifically and talk a little bit about kind of pros and cons. So, typically organizations look to unit testing for a few reasons. They're quick to execute. You can execute them right at the beginning of your CI/CD pipeline, so you're going to get quick feedback. They're more granular, so they're easier to diagnose. They also have a much simpler test environment. You're also going to actually get better designed code if you build a unit testing practice in alignment with your active development. I'll talk about that again a little bit at the end of today's session. But the thing about unit testing is it is a best practice that can really help you build more reliable code because of the process and the practice itself. Now, there are a number of cons though. Typically, it requires a higher skill set to do unit testing because you are closer to the code versus manual testing or automated UI testing. And often many organizations struggle with the conflict somewhat that you're doing a test at the code level and trying to figure out how that maps back to your end-to-end business scenarios. And one of the biggest challenges that we face and we hear is that, frankly, people just don't like doing it. And in fact, when we talk to developers at trade shows and conferences and things like that, and we talk to them about unit testing, typically visions of going to the dentist, having to have that thing done, or I've got a backlog of mail and bills that I need to address, or I'm walking into somebody else's problem. Your teenager's bedroom that's just a complete mess. You didn't create that mess, but you're now being asked to fix it. And a not uncommon response, and this is actually a direct quote, is that people respond saying they hate unit testing. They see the negatives much more than they see the positives. So what we're going to talk about today is how we can focus on 4 key areas to, in essence, eliminate those challenges and set up your unit testing practice in the right way from the start. And as I said, Brian is going to talk about each of these. We're going to go through the specific technical details, and hopefully as you come away from today's session, you'll have some great ideas as to how you can improve your testing practice, how you can actually drive the team towards the coverage goals that the business owners, product owners within the organization are looking for. So with that being said, let's start on the first best practice. And Brian, I'm going to turn it over to you. Go ahead and talk about the best practices that we need to have put in place to establish a good testing practice.
Sure. Thank you, Mark. And when we're talking about best practices, really a big part of what we're talking about is what we actually need from the unit tests themselves, right? There are certain things that we need our unit tests to be. In particular, one of the most important things that they should be is they should be trustworthy, right? A test that I write needs to fail if the code is broken, but only if the code is broken, right? If it doesn't, then we can't trust what the test results are telling us. So tests need to be trustworthy. They also need to be maintainable and readable, right? When production code changes, tests often are going to need to be updated. They're possibly going to need to be debugged as well. So it needs to be easy to read and understand those tests, not only for whoever wrote it, but for other developers in the organization as well. So we want to organize those tests. We want to name them for clarity and readability. We want to make it easy to understand them so that they can be updated when they need to be. Another thing that tests need to be is they need to be verifying a single use case. And really what we're talking about here is a single business use case or a single flow through the code, right? Good tests tend to validate one thing and only one thing, right? So they are going to validate that single use case. Tests that follow this best practice, they tend to be simpler and more understandable, and that's good for the maintainability and debugging item that we were just talking about. Tests that tend to validate more than one thing, those can very easily become complex and time-consuming to maintain, so we don't want to let this happen. Another really good practice is to use a minimized number of assertions. And this is part of verifying a single use case. Some people even recommend just one assertion per test, which I find to be a little bit too restrictive. There are cases where you might need a few more, but the idea there is to focus a specific test on validating only what is needed for the specific use case that that test is for. Okay. Another really good practice with unit testing is that unit tests themselves should be isolated from each other. They should be runnable on any machine in any order without affecting each other. If possible, those tests should have no dependencies on things like environmental factors or global or other external states. Tests that do have those dependencies are generally harder to run. They're unstable. They're harder to debug. They're harder to fix. And in the long run, they end up costing a lot more time than they end up saving, right? Especially because they tend not to be trustworthy. So we want to write these tests to have a minimum amount of side effects. And the final thing that we strongly recommend is that unit tests should be automated, right? Make sure that those tests are being run in an automated process. And this can be, run them once a day, run them once an hour. You can run them as part of a continuous integration or a continuous delivery process, but run them regularly and run them often. The reports that come out of that should be accessible. They should be accessible to and reviewed by everybody on the team so that everybody's aware of what the state of the tests is, what's working and what's not. Now, as a team, you can also talk about what metrics you want to be tracking related to those unit tests. Maybe you care about the code coverage. Maybe you care about modified code coverage, which we'll talk a little bit about later. Maybe you care about how many tests are being run or the performance of the application, et cetera. A lot can be learned by looking at these numbers, and big shifts in those numbers often indicates issues with either the testing infrastructure or with the application. And by running them regularly, you can address those concerns immediately. Okay, so with all of these items, I'm going to go ahead and switch to showing you. Oops, I'm gonna... Okay, and I'm hoping that everybody can see my screen. So what I want to do is I want to take an example class, and this example class is representing a bank account. And what I want to do is just kind of show how I can use some of these best practices to generate some tests for this class that are going to follow those best practices, but also are going to get me as good a coverage as I can get for the code under test. So here I have this method, and you can see there's a fair bit of logic in this method. And let's say that I want to start by focusing on this method and make sure that I have some good tests here. So the first thing that I'm going to do, I'm going to go ahead and just generate a quick empty test for this. And you can see that, initially I have this fairly straightforward generated test. I have a test for the method that I'm focused on, but there's probably a few things that I need to set up. So if you saw, I actually used JTest action to generate this, and it gave me some defaults here. So let's go ahead and create this object that my method, or that my object under test needs. So let's just give them some example values. And I like to remove these comments when I've set them up. So here I've constructed a customer object with some values. Now I'm going to construct an account object. This is the actual object that I'm going to be testing. Remember, I'm testing account. and he needs that customer, and he gets an initial balance, which an initial balance for the bank account, I'll just leave it at 0 for now. I don't really need to set something. And then what my test is going to do is it's going to run this overdrawn method, right, which is the thing that I'm testing. And what this method does is it takes a balance, and it's going to tell me whether or not this bank account at this balance would be overdrawn. So if I want this test to do something useful, let's give it an actual balance. So I'm going to set it to 100. So I would expect when I run this that this bank account would not be overdrawn with a $100 balance. So my test is going to get that result, and it's going to verify that, that the result coming back is correct. So I'm going to uncomment my assertion here, and I actually expect is overdrawn to return false. So my example assertion is correct. Now there's a couple of things to notice about how we've structured this. The first is obviously the test class for the object under test has a standardized name. So for instance, account test is the test for the account class. And my test method has a nice name as well. It's testing the isOverdrawn method. I actually could give this a slightly better name because this isn't just testing isOverdrawn. This is testing a specific use case of isOverdrawn where I have a non-zero balance, a positive non-zero balance. So let's give this test an actual display name. So test is overdrawn with positive balance. And I need to make sure that I import things. So by naming this test, I've actually given myself some idea of what the use case is. And I can even put things in here about what I expect from the method under test. So let's go ahead and run this. And you can see my test ran and it passed. And I can even see the name of my test in here. So I've got this nice long description. So not only when this runs in my IDE, but also when this runs as part of my automated process, I can see that this particular use case, this particular workflow is running and it's passing correctly. And if it were to fail, I would know what the actual circumstances are in which it's failing. Okay. Now there's one other thing that I can take a look at, which is important, which is how much of isOverdrawn am I actually testing? How much of its behavior am I validating? So if I go back here, you can see these red and green markers on the side. And you can see that when I ran my test, I was covering these lines here, the ones marked green, but I did not cover any of these cases, right? And that's to be expected because I gave it a positive balance. So it went into this block and it returned false. So probably the next thing that I would want to do if I was to completely cover this entire method is I need to give it some other balances so that it'll go into some of these other blocks. One way to do that, because I just ran my test, is to take a look at the recommendations. JTest is actually pretty handy here in terms of showing me blocks that I could cover. So actually here's one that's part of my method under test. And I'm going to use this clone test action to go ahead and just create a copy of my original. So what this did is it created a copy of my original, and it actually updated the balance for me. So really without doing too much else, I could run this and get a little bit better coverage. What I'm going to do though is I'm going to update the name of this so that it's a little bit clearer. And if I'm testing with a negative balance, is overdrawn should be true. So I need to update my assertion. Okay. Now I can run all of my tests. So I have both of the tests run, and my coverage went up. Not only do I have the green and red markers, right, and I can see that this block is now covered, but also if I look over at my coverage view, I can see in account, I have some coverage for is overdrawn. And actually, I'm already up to 64%. So let's go ahead and do this one more time. And what I'm going to do is use this quick fix one more time. And that'll automatically set this up. This now has a very, very negative balance. And now I can run all the tests again. And you can see that I'm now up to 100% coverage. So that's a nice way of basically creating a series of tests here where I'm able to get pretty good coverage on my test. And just one more time, some of the important things here in terms of best practices include things like setting the display name for the test. We can organize the test into sections here so that it's very clear. This is a setup section. This is the test action itself, and I can put my assertions down here. Each test only has one assertion, so I'm setting it up in a very specific way, and I'm getting a very specific result. And they're very clear when they, if one of them were to fail, it would be very clear why. Right? If I change my expected and one of them fails, I can clearly see that I expected one thing but got something else. Okay, so let's go back to our slides. I'm going to stop sharing here.
Great. So thank you, Brian. So I think one of the things that we should highlight, let's see if we can get the slides. There we go. Okay, so some of our key best practices there, right? So the tests need to be trustworthy. So they need to be stable. They need to be repeatable. They need to be maintainable, so that when I modify my code, I do need to modify my tests. Also, some of the things that Brian was doing there. So he was taking a test case that was validating a specific case. It was isolated. It was not dependent upon others. And he was duplicating that, modifying it, or cloning, to use the word within JTest, cloning it, modifying the data values so that we can get very quick, independent, isolated test cases. And this is a great first step in driving the code coverage. So what you're doing there is you're taking an existing test and modifying it to drive code coverage. But there are other techniques that we want to be able to go into as well, because not every test is going to be as completely isolated and just down to an individual method and no external dependencies. So Brian, why don't we talk about other techniques here for maximizing the test coverage?
Sure, and let me share my screen actually. I'm going to come back to the slide. Can we switch to the IDE?
Yep.
Okay, so one of the techniques that we can use actually to increase coverage is to use parameterization of the tests. So the way that this works, and one of the reasons why this is very helpful, is because if you noticed when I was generating tests just a minute ago, most of these tests are basically identical. I'm using the same values for the customer. I'm using the same, constructs up here in general. The only real difference between these various tests is the actual balance that I'm passing in, the input, and then the expected value, right? So whether or not result was true or false. So one of the ways that you can increase coverage, and I'm actually going to start this over here, is to generate parameterized tests. Because what this allows you to do is actually to manage the inputs and the outputs of the code under test in sort of a data managed kind of a way. So I'm going to go ahead and generate a quick parameterized test. So this is very similar to the test that I had generated just a minute ago. You can see that it's annotated as a parameterized test. And what this is going to do is it's going to test is overdrawn in the same way that we did before, but it's going to allow me to essentially specify the balance and whether or not is overdrawn will return true or false based on a set of arguments down here. So similarly to before, I'm going to set up my customer. Let's clean this up again. And once again, I don't actually care too much about the initial balance. But one of the things that you'll notice is that there's no variable down here for the balance that I'm passing in because it's parameterized. And the assertion is also updated. So whether I expect true or false to come back here for is overdrawn is actually part of the assertion now. And it's coming from the raw data. So now what I can do is I can come down here to where the data is set up, and I can set up the expected input here. In this case, the balance would be 100, and set up that false return value. So this is actually the same thing as my first test from before. Okay, so how do we increase coverage? Well, we add more rows. Remember, I wanted to use a negative balance. It is overdrawn should be true. And maybe a very negative balance. Result should be true. So in a way, this is the same 3 tests that I had before. And if I run this again, we will see that I'm basically running the same 3 tests as before. Now, where this gets really interesting is I can add many more use cases to cover some of the corner cases or some of the boundary conditions. For instance, I'm passing in -500 as one of my cases. Maybe I also care about -501. So I can add multiple variations of my data in here and verify not only what my inputs are, but I can put the expected values here as well. So this allows me to kind of expand how much of the code that I can cover without necessarily having to build entirely new tests for every single case. Okay, let's go back to the slides for just a moment. Okay, so another way to expand coverage in terms of unit tests is another thing which is related to a concept that we talk about, which is solitary tests versus sociable tests. So let me just explain that for a moment. So a few years ago, Martin Fowler, if you know who that is, wrote an article about this. And he used the terms solitary and sociable code to describe how dependency usage works in application code and how tests need to be designed accordingly. So in his article, solitary code doesn't depend on other units, right? It's more self-contained, whereas sociable code does interact with other components. Now, if the application code is solitary, then the test is very simple, right? As a matter of fact, we were just looking at some tests which were very self-contained. But for a sociable code that we need to test, you can either build the test for it as either a solitary test or a sociable test. So a sociable test would rely on real dependencies in order to validate behavior, whereas a solitary test is going to isolate that code under test from those dependencies. One of the ways that you can create solitary tests for sociable code is to use a mocking library. So you can use mocks to isolate the code under test and build those solitary tests for that sociable code. So let's go ahead and take a look at how to do that. So I'm going to switch back to Eclipse again. And an example of where we might need this is in another method that we have here. So here we have a method that, for this bank account, tries to apply a transaction. Now there's multiple kinds of transactions in my application. I might have a deposit or I might have a withdrawal. And the behavior of this method depends on the behavior of that transaction. So here you can see I make a call for, to
Brian,
apply on this transaction. And
Brian,
yeah.
I can't actually see your ID. I think the sharing didn't transfer.
I apologize. Let me try again. Okay, is that better?
Great, that's it. Thank you.
Okay, apologies. So here's my apply method, and here's the transaction I was talking about. So it takes this transaction, it tries to apply it on this bank account, and if applying it was successful, then it adjusts the balance of the bank account. So the behavior of this method, which we want to test, is actually dependent on the behavior of this code. So this is an example of sociable code that we want to test. And since we actually want to just create a test for apply, in this case, maybe I don't actually care about testing the behavior of transaction. I just want to verify the behavior of this code. What I can do is I can isolate the behavior of the transaction from the behavior of apply. So here's an example of how I might do that. Let me go ahead and create, just like before, a test for the apply method. And what this does, and now I use JTest for this, so this sets some stuff up for me automatically, which is kind of nice. But what I want to point out is that, just like before, it initializes the account, but then the transaction that needs to get passed to the method under test is actually mocked. So what this is going to do is this is going to use Mockito, and if I mouse over this, you can actually see this is a Mockito function. It creates a mock object that is an iTransaction without being any particular hard version of iTransaction. And with this mock, I can then decide what its behavior should be. So using the Mockito syntax, it says when I call transaction.apply, and I'll talk about what this is in just a moment, but this is basically saying if I call transaction.apply with any account, I want to return this result. And if you remember from here, it's calling that method. And in order to cover this line, I have to get into the block. So I need this to return true. So what I'm going to say is the result that I want is going to be true. I can also control what this call does, because this is another call on the mock. So what I'm going to do in my test is I'm going to verify the use case where I call apply with a transaction. I want apply to be successful. And then I want to see this balance adjust based on what comes back from fee. So let's give it a non-zero fee. Let's say my fee is $10, which sounds awfully expensive, but such things happen. So when I call the fee method, I want to say this should be 10. And this little helper method is going to return my transaction object, which is going to get passed into my method under test. Now remember, I said I want to verify that that gets applied. So let's create an assertion here in my test. Let's say that if I call under test.get balance, and that's after I apply the transaction, that the balance should be 90. So I would imagine then that the initial balance should be 100. Whoops, that's a little big. Should be 100, so that when I apply a fee of 10, I should now have a balance of 90. And just to set everything up, let's go ahead and do that. Oops, that was the wrong button. That's okay. So we ran my test, and I can see that it passed. Oh, yeah, I hit the wrong button, so it added some things that I didn't actually want. That's fine. But I'm able to run my test, and I can see after the apply that my assertion that the new balance is 90 is in fact passing. And if I go to my code under test, I can see that it's completely covered all of this. And at no point did I actually create a real transaction object. Okay, so let's take a look at the slides again. I'm going to stop sharing. And I think, Mark, you're muted.
Yeah, trying to find the mute button on Zoom is a problem sometimes. Yeah, so thank you, Brian. So what we've gone through here is we've gone through creating a test that's well structured, that's isolated. We then duplicated those tests to increase code coverage. We then said, well, there's actually a more efficient way to do that. You're really just changing parameters within the test. So let's go ahead and parameterize that and then data drive them with a managed data set. That in the particular scenario that Brian was showing us there, that data set's managed in the code. That could be in a CSV file or some kind of external data source as well. The point here is that you're able to both increase code coverage though, but also increase functional or test coverage. So remember, Brian actually put in a data value of, I think it was -501. Wouldn't have actually increased the code coverage much, but it would have increased the functional coverage. You're testing different boundary conditions and corner cases, max int, min int. If you've got a string, maybe you want to test with some specific character lengths or particular characters that are being used in somebody's name, for example. Parameterization is a great way to do that. Then secondly, what we were just looking at was the use of mocks. Mocks are a very powerful way of taking a test that is very difficult to do because it's social in nature and it requires a lot of external dependencies, and making it solitary, isolating it so it can be run independently, so that it can be run quickly without a lot of those external dependencies. That's one of the best techniques to start increasing code coverage when you're focused in a particular area and around a particular use case. You can use the mock objects that we saw there, but you can also use concepts such as stubbing as well to isolate specific method calls as part of the execution process too. So these two techniques are really critical to help you maximize the code coverage. So at this point, I've now started building a test suite, and I've got a lot of tests. This normally what happens is you start by having a small number, but as you're driving towards code coverage, the number of tests is going to increase, and also the complexity of those tests are going to increase. So the question now is, how do I still get the quick feedback on the work that I'm doing, and more importantly, on the changes that I'm making to the code base? So if you think about the tests that you're creating, you want to ask yourself a question, which is, when are you going to run those tests? Well, the first time you're going to run those tests is from within the IDE. Brian's showing us a clip today. That could be IntelliJ, could be some a Visual Studio code, for example. You would want to run those tests within the IDE, and you need to get quick feedback. If your test suite takes minutes to run, then you're in essence wasting cycles waiting for your test execution to complete. So typically a best practice is to say, I want to run my tests in about a minute within my IDE before I check into source control. So I know that the work that I've done is valid and safe. The problem is, as you start building more and more tests, and then we'll talk a little bit more about the types of tests as well, that actually time window is stretched. So often folks will start to use something like a commit suite. In essence, a small set of smoke tests that you can use to validate that you're not breaking any critical functionality, and then go ahead and commit into source control and leverage your CI to kind of run the full test suite. Now, typically, most people would expect that a CI test execution of unit tests typically takes between 10 and 20 minutes. But again, you're going to start hitting the limits of that time window very quickly. You're going to hit those limits as you increase the number of tests you are running, but also as you start to move a little further up in that testing pyramid. So what many people will do is to start to integrate in integration tests into their unit testing framework. So this is where your tests become more sociable. They require more external dependencies. They take longer to run. And then what happens then is you then start separating out your CI test suite from a full nightly regression, which is kind of one of the things Brian was talking about before. I'll give you an example. At Parasoft, we have a product called SOA Test. It's an API testing solution for web services, RESTful services, as well as custom protocols. The product has been on the market over 15 years. So you can imagine that there are a lot of tests that need to be run against that application. And in fact, there's about 4,000 of them. So to run a full test suite or a full test automation that covers not only unit tests, but also further up the testing pyramid, takes about 5 hours. So really, if you are making a change in the code base, when do you actually know, when are you actually sure that you've tested that change? Well, the trouble is I'm subsetting my suite. So I might actually pass my commit suite. I might pass my CI run. But when I get to the nightly run, that's actually when I can be 100% sure that I've tested the change that I just made. The trouble is, if I'm waiting until the next day, I've lost a lot of that contextual information about what I'm actually testing. So there is a better way to do this, and it's actually to leverage the code coverage that you're capturing during your unit test execution, and leverage that code coverage to understand what parts of the code base a particular test is touching, then determine which parts of the code are actually changing, and use that intersection to actually focus on executing just the subset of tests that are required to validate the changes that you're doing right there within your IDE. This takes out all of the guesswork of trying to figure out which tests I need to run to be able to validate my local changes. We can also start to look at optimizing your CI pipeline as well, so you're keeping that rapid intra-daily update by executing the subset of tests. So Brian, I know we are running a little tight on time, but could you just show us a little bit there of how that works inside of the IDE workflow?
Sure, Mark. Let me go ahead and share my screen one more time here. So Here, just kind of going back to the example that we've been looking at, I have my account code, I have my test, right? I've run it and I can see some of my coverage. So one of the things that I can do is once I've run this and I have my coverage information, let's say that I want to go into my code under test and I want to make some changes. And I know that this code is actually covered by some tests. So let's say that I make this change. Now, when I do this, in JTest, I have this view where I can look at any of the unit tests which are in my project, which would be impacted by the local changes that I have. So I'm about to make a local change here. And when I save that, you can see that this just populated because it noticed the change. And it's going to say, oh, your test for that class needs to be rerun. And there's actually this other test which you may not have realized is related to the code that you just changed. So these would both need to be rerun in order to validate the behavior. And so if I now go in here, I can just run these tests directly from here. And I can see that, in fact, I do have a test now that is failing. And I probably need to go in here and update the assertion because I just changed the expected behavior. So let's go in here and let's actually update my assertion. And now I can rerun my impacted tests and I can see that they're now passing. So one of the big upsides to this, as Mark mentioned, is that I'm only really running a subset of all the tests in my project. These are just the tests that are impacted by my local changes. And this helps me to focus on those tests based on changing code so that I know what to run locally, but I also know if there's any tests that need to be updated or things that need to be looked at, so I can detect things like regressions before I'm actually publishing code.
Great. So this gives us the ability to kind of get that immediate feedback in the CI. Sorry, in the IDE. Could you start sharing for a second, Brian, and then I'll go.
Sure.
Great, thank you. So this gives us the feedback in the IDE as to what's going on and making sure that I'm able to execute the test. The interesting thing there, though, is what Brian was doing was he was actually leveraging the coverage information from his full nightly run. So you can actually leverage this type of technique and use your coverage to help you optimize both IDE workflows as well as your CI workflows as well. So our full CI test run, for example, here you can see this is actually from our SOA test product. 4,500 unit tests that are being run against the code base, and it's being run every night. That gives us this big coverage image that tells us about every test and about what parts of the code base that are being used. And then that coverage image can be leveraged both by IDE workflows, such as what Brian was showing, but then also during the course of the day as part of the CI workflow. So here you can see on the chart on the right-hand side, using test impact analysis, we're able to execute a subset of those tests and give immediate feedback to the developers on the integration tests that are being executed as part of the CI process. And then you're still running the backup of the nightly test suite that's running that 5-hour test run. But here what you're doing is you're really leveraging the power of CI to give you quick and immediate feedback into the process. So this ultimately means that we're going to go quicker. We're going to get the feedback. We're going to get feedback on the changes that I've made in the application quicker. But what about when I'm actually trying to test legacy code? This is obviously 90% of people's situations. Very rarely are you walking into a situation where you've got a greenfield project and that you are you're started from ground zero. You're normally walking into some existing code or legacy code. Michael Feathers defines legacy code as code that doesn't have tests. There's very rarely code out there that doesn't have any tests. It's important to think about, though, how is that application being tested? So how are organizations doing testing today? If you're struggling with unit testing, if you've got low code coverage numbers, you're trying to drive them, well, you've got to be testing it some way today. And the reality is that most people, when you look at the testing pyramid, would agree that this is the right strategy. Normally, most organizations would self-identify with an inverted pyramid or an ice cream cone, where you've got more UI centric testing practices in place because they're quicker to define. UIs are intuitive, so that they're, it's easier for you to just push a few buttons than to try and think about the underlying code and the unit testing infrastructure that you would potentially need to be able to isolate the code and isolate the use cases. So the question is, can we leverage these tests to help us get a jump start on our legacy application and really optimize the efforts of unit testing so we can get the best bang for the buck, the bigger ROI of our unit testing practice? And there's really two parts to this. The first part is to take the code coverage from each of those layers of the testing pyramid. Capture the code coverage during your automated UI, your automated API, your manual testing, and combine these together. Now, obviously, what you can't do is you can't simply add these numbers together, because if you do that, well, clearly see here, you'll get over 100%, because these different tests are actually overlapping. So you're going to be touching the same piece of code. What you want to do is you want to merge those together into a centralized view of your code coverage, and helps you identify what parts of the code base still need to be exercised. So here, by taking the existing testing practice for this example project, you can see we have about 35% of the code base that's not tested by anything. That would be a good part of the code base to start focusing on, and start drilling into what parts of the code base, what use cases, what areas are actually not tested in any way today, and focusing our unit testing around that. But really, that's only one half of the problem. The other question you have to ask yourself when you're addressing legacy code base is the part of the code base that's not exercised at risk? And really, you have to go back to the fundamentals of why you're doing this in the first place. The goal of organizations pushing towards having high levels of code coverage is to ultimately improve the quality of the application. But if you don't have sufficient coverage on the parts of the code that you're modifying, then you run the risk of introducing regressions into the application. You could argue that if your code base has not been touched for 5 years, then you could argue that that part of the code base is stable, and therefore, it in itself is not going to start introducing regressions. Where it will introduce regressions is where you've identified a defect and you're going in there and fixing it, or you've identified an enhancement or a new feature that needs to be worked on. So really, what we do recommend, and we do this at Parasoft across all of our development teams, is we focus not only on code coverage at a macro level of the entire project, but we focus on code coverage from the point of view of a sprint to sprint and release to release perspective. So we're looking at the parts of the code base that have changed from one sprint to the next, and from the last release to the release that we're currently working on. And we're focusing on achieving high levels of code coverage there first. We want to do this because this actually gives us confidence in what is being built today is actually of high quality. And it also provides the biggest value to the teams. There's nothing more demoralizing than saying to somebody, here's a legacy code base that's not been touched for 10 years. I want you to get it to 80% code coverage. The question in your mind is why? It doesn't matter. But if you're working on the code that's active, the code that's being changed, this is where the business risk is. It has the highest value for the team, and it'll help you establish the practice of testing early, so that when you do go back to those older parts of the code base and you start doing refactoring, you've got the practices, you've got the muscles built, and you're able to accelerate forward. The goal here is all about how we can really help accelerate the modifications of existing applications and do it with confidence, knowing that you can just run forward, whether or not your shoelace is tied, and be able to make those changes to the legacy application without running into potentially the risks of introducing regressions. So there are two approaches that we can do here. So first of all, you're going to take your existing code coverage from up and down the testing pyramid and target your new testing practices around the deficits, the gaps. And then furthermore, prioritize the work where you're introducing code changes and where you're introducing modifications to really get the best value from the testing practice as a whole. Now, we have a few questions, so we'll jump into those. As we've been going through today's session, we have been using Parasoft JTest for kind of streamlining the creation process. You'll see there as Brian was creating his tests and talking about the best practices, that JTest just handled all of that for him. So it's all about helping streamline the process of creating the unit tests, as well as building secure and reliable code. As I talked about at the beginning of today's presentation, a testing practice built on top of poorly constructed code is not going to build quality into the application. So if you are interested in learning more about Parasoft JTest, if you'd like to get access to have a demonstration, get access to a free trial, go ahead and click on this link. There's a QR code here for those that are that inclined can scan. And then also we have an ebook around unit testing, which covers some of the topics that Brian talked about today, as well as others, and really kind of pulls together a lot of the content that Parasoft have published, both within our blogs as well as within industry articles as well. So I would definitely recommend that as a read for helping you improve your testing practice. Okay, so we are a little close to time. I am going to look at the questions here though. So I'm going to start filtering some of these, Brian. So I'm actually going to throw one at you just out the gate here. Sure. What are the best practices for complex object initialization? This one actually appeared when you were showing the your test case where you were kind of adding John Smith and his social security number around the customer. So.
Yeah, so, and I assume we're talking about the situation where, you know, a test needs some sort of a complex object initialized with values. And that complex object, maybe it's potentially composed of other objects too. So sometimes mocking can make these initializations simpler, but oftentimes it doesn't. One thing that I often recommend for those is to use things like factory methods or use a builder pattern. These are often used for complex objects in the application code anyway. So if you leverage those in the test code also, then that makes your job a little bit easier. In cases where these aren't available though, you can create those factory methods or builders specifically for your testing needs and then reuse them, right? So this will reduce your code duplication in your test. It can make them more readable, more maintainable. And JTest can leverage those factory methods too when it's generating test code.
Great, thank you, Brian. Okay, so the next one here, I think is kind of somewhat similar. Your examples are all POJOs, so plain old Java objects. Do these techniques change when we are testing a Spring application?
Yeah, certainly. You know, the primary techniques and best practices, especially the ones we were looking at, are very much the same when you're using an application framework like Spring. There are often additional recommendations when testing an application like that. For instance, dependency management is very important in Spring. So the isolated versus sociable question becomes more important because, you know, sociable tests tend to be more realistic, but they're also a lot slower. So you can use things like what we've shown today, like Mockito, that can be very powerful for Spring tests in order to create the fast isolated tests. And then oftentimes these application frameworks come with helper APIs to assist in creating and running those tests. So I would definitely recommend leveraging those as well.
Great. I think we're going to have a couple more questions here. So okay, this one's written a little weirdly. Okay, so how should unit tests handle exceptions? Okay, I think that's probably the right way. Yeah.
Okay. So I've seen tests before which use, try-catch blocks to handle checked exceptions. Usually I recommend not to do that. Remember that the test method itself can actually throw exceptions. So any unexpected exception can automatically get thrown by JUnit, and JUnit handles that for you, right? It becomes a test failure with a stack trace. Usually that's sufficient to kind of understand why the test failed, because you can see that information. But I don't recommend trying to just catch the exception and call fail or something like that. There's also other situations where you can have expected exceptions which can just be ignored. In those cases, you can use a try-catch block just to ignore the failure. And then there's cases where you might want to verify that the method under test actually throws an expected exception. So that's a very interesting case because essentially what you're doing is negative testing. Now JUnit can handle that case for you because there's constructs in both JUnit 4 and JUnit 5 to define that the test expects a certain exception to be thrown. So I would use those if possible. I think there's also kind of an additional question there though, or a related question, which is, what about cases where in the code under test, there's exceptions being thrown there and being handled in that code under test, right? How do I test the catch blocks, right? And so that's actually a really good place to use mocking, because with the mocking, and we showed a little bit of mocking earlier, but what we didn't have time to get to was the ability to tell the mock to throw exceptions for certain method calls. But you can do that, and then by doing that, you can cause the test to enter those catch blocks, to cover those catch blocks. So I would use mocking to cover those sorts of cases.
Good. You covered everything that I was thinking of there as well. So yeah,
Okay.
it's a pretty exception use cases. That's kind of your 80-20 rule as well for me. So there's exception parts of the code base are often areas where are a little bit more difficult to test, but leveraging mocking frameworks and leveraging JUnit's capabilities for validating those scenarios is definitely the right approach. Okay, we've got a last question. I think I'll take it because it's talking about legacy code. And it says, for legacy code, can I just automatically generate the test for my entire project? Okay, so Brian showed us the kind of the button clicking there where he was creating some initial tests and he created some parameterized tests, and JTest has a lot of helper functionality there. That is available in what we would refer to as a bulk operation. So yes, you can kind of point JTest at a class or a package or a part of the code base and just tell it, start creating me the tests. Now, what you did notice though, is as Brian was working with those tests, he's putting kind of human logic into those. So, you've got to be a little careful there. It's not just a shotgun fire and connect and forget. What you want to do is you want to use that capability in a targeted way. So when we were talking about the legacy code base, and we were talking about bringing in the coverage from all of the different types of testing practices, that 35% of the code that still wasn't covered, that's the candidate for saying, do I want to apply that test generation in a bulk way? And then likewise, if I'm going to go in and touch a part of the legacy code, if I know that I'm going to start fixing a defect and I need to touch these classes and they have no test coverage, that's the place to use that technique. Because what you're going to do there is, in essence, shotgun and bulletproof that part of the code base before you go in and start making changes. Because really, that's the important thing when you're talking about legacy code is, do I have coverage before I make the changes? There are other techniques that Parasoft has within our portfolio as well. We can actually start giving you coverage reports targeted on specific parts of the application. So one of the things we were doing at Parasoft, we went through a refactoring effort on our reporting and analytics dashboard. And before we did that, the team actually isolated the parts of the code, identified the parts of the code where they needed to make these significant changes, and then used our coverage reporting to make sure that they had 100% coverage of that part of the code before they went in and made any changes. So yes, short answer to your question is yes, you can use JTest's test generation functionality in bulk and kind of point it at a package or a project level. What I would say is you want to do that in a targeted manner, because you want to make sure that you're doing it as part of a practice that's going to make sure you build reliable, stable code bases moving forward. So with that being said, it looks like the team were also addressing some of the other answers offline, and we are a little over. So I will say thank you very much. Any questions which didn't get answered, we'll be following up on, and please feel free to reach out to the Parasoft team. If you've got any questions, if you'd like to have kind of a consultation about your challenges and how to approach them, how we might be able to help, please feel free to reach out. So with that being said, Brian, thank you very much for doing all the heavy lifting today. I really appreciate it. Thank you, everybody. Thank you very much for everybody for your time today. Please be safe, and please have a great rest of your day and rest of your week. Bye-bye.